Okay, welcome to example 11. This is a really nice problem because it involves more than one topic, more than one chapter. You've got a collision between a bullet that hits this block. It's going to become embedded within the block, and then the block and the bullet system will then fly off here and follow this trajectory, and this is really projectile motion. So you're given the horizontal displacement, 1.6 meters. You're given the vertical displacement. It's on this post, so it's 1.5 meters high. And what you're asked to find out is what is the velocity of the bullet initially. So let's label some things. Let's call the bullet M1. I believe we're given that mass. That is 0.010 kilograms. We have this block here, M2, and that block has a mass of 0.5 kilograms. And then we have this distance. Let's call that your y initial. And then let's call this x distance, 1.6 meters. So what we need to do, if you look at this problem carefully, is we're trying to find velocity 1 initially. So you have to think about this problem in stages. You have to think, well, the block eventually ends up here, striking at some velocity here. We don't know that, but we do know how far horizontally it goes and how high it came from. So we have to work backwards and find out what was the velocity of this block as it was moving off the post horizontally initially, because this is coming in that way in a horizontal direction. So we need to find out that Vx, which is really the final velocity of the block after the collision of the bullet within the block when they're embedded together. Now, hopefully you realize that the block initially, as the bullet comes towards it, has no velocity. So you've got this completely inelastic collision, and then you've got the projectile motion. And you have to think backwards as you work your way to solve this problem. It's a great problem because it's got projectile motion mixed in with collisions, completely inelastic collision. So let's recall how we would solve this using projectile motion. How to find that horizontal velocity initially. We've got the horizontal distance, we've got the vertical distance. Hopefully you realize also that the acceleration while it's in the air is negative 9.8 meters per second squared. So let's use our kinematics to figure out the time in the air. So that's our first step. Use y equals y0 plus v0 yt plus 1/2 ayt squared, and that acceleration in the vertical direction is negative 9.8. Now your final y, when it gets down to the ground, is 0. Your initial y is 1.5 meters. Hopefully you realize that this is going to leave horizontally, so therefore the initial vertical velocity is 0. So plus 0 plus 1/2 times negative 9.8 meters per second squared times t squared, and go ahead and solve for t, and I get 0.553 seconds. So now that you know the time in the air, we can find that horizontal speed by using our x equation. X equals x0 plus v0x times t plus 1/2 axt squared. If you recall, this is projectile motion. There is no acceleration horizontally, so this goes to 0. Let's assume the initial position is 0. And so what we have is this final place that it moves horizontally is 1.6 meters equals the initial horizontal speed times the time that we just calculated, which was 0.553 seconds. And go ahead and calculate that. And you should get an initial horizontal speed of 2.89 meters per second. So the next step is then to look at the collision between the bullet and the block. So I like to draw pictures, so I'm going to draw two pictures here, one before and one after the collision. So there's the before picture, the bullet moving at this unknown initial velocity, the block sitting here by itself, and then the block and the bullet embedded within here, this bullet, and it's moving at this final velocity. Now, what's that final velocity? Hopefully you realize you've already calculated it. It's actually 2.89 meters per second. It was the initial horizontal velocity in our projectile motion problem. So now we apply conservation of momentum. So the momentum initially is equal to the momentum finally. We have the mass of the bullet times velocity 1 initially, plus the mass of the block times velocity 2 initially. Hopefully you recall that. We'll go to 0 because this was at rest initially on the post. And then the final momentum of it combined in this inelastic collision, we have m1 plus m2 times v final. So go ahead and substitute numbers in. You know m1 is 0.01 kilograms times v1 initial equals 0.01 kilograms plus the mass of the block 0.5 kilograms times this velocity we just figured out, 2.89 meters per second. And go ahead and put that in your calculator. And you get a velocity 1 initially of 147 meters per second. And that's it for example 11. And we're done with the chapter 7 notes.